Okay, so we have left this expression in the last class. I don't know why the video got interrupted. So we will start from this particular portion, and after writing the expression we have just multiplied the logarithmic term on the both the sides, and just we will actually separate the terms which we needed and separate from the terms which we do not need. Actually, this term we both consider to this is a constant, this is a constant, this is also a constant, and I have considered this is a constant, therefore considering this to be k node kbt, let us say kbt, and this is the multiplication. That means this will be equal to delta G activation non-electrostatic contribution due to the free energy ln of E, that is equal to 1 minus of ZA into ZB E square by EKPTT. We are just using the ln A into B is ln A plus ln B. We are using the formula ln A, and we already know ln is 1. Therefore considering both the terms, to be involved, and we are saying this to be ln k node minus of ZA into ZB epsilon square by epsilon k bt dAB. This is the first expression which we have derived, and what is the equation number? This is the equation number 6th. And if we try to draw the, this is the y, this is, if we will try to put for 1 by epsilon, that is your x, m will be minus of ZA ZB into E square, and this is the y intercept. So therefore here y is equal to ln of k, x is equal to 1 by epsilon. In the x-axis we will take the reciprocal of the dielectric constant and c obviously will be the ln k node, and m is equal to minus of ZA ZB E square divided by kbt dAB. Okay, that means our slope is negative, and this is according with a straight line. So we will get, whenever we will plot let us take the scale and just plot. Okay, so I will get, in the x-axis I will get ln of k, and this is one by epsilon. I will get a straight line, and this y-intercept is in nothing but your ln of k naught. Y-intercept is the distance on the y-axis, and this is positive. This means on the positive y-axis it will cut, and this is your straight line which will have a slope of equal to minus ZA into ZB is square divided by KBT DAB. That means this slope, the slope of the straight line is proportional to the product of charges and inversely proportional to temperature, also inversely proportional to the maximum distance a ion can approach. So this should be remembered. In the similar fashion, if I take this ln k node to be this side and we will use ln a minus ln b to be ln a by b, then our expression can be rewritten in the form of ln k by k node is equal to minus of za into zb e square divided by epsilon k t k b t dab, and this is the equation number 7th. In the similar fashion, if we draw a plot taking this to be y and x to be taken as 1 by epsilon and m, then zb e square by dab minus will be the slope, and so therefore as there is no y-intercept is there, we will get a straight line as the slope is negative. I think we should get like this, and this slope is equal to minus ZA ZB into E square KT DAB. And we have taken x-axis. Okay. So from the equation number 6th, we can write that equation 6th predicts that the logarithm of the rate constant, that is ln of k, rate constant of reaction between the ions should vary linearly with the reciprocal of the dielectric constant. linear plot we have got. That's what we have written with the reciprocal of the dielectric constant. Okay. So now we have already calculated the free energy. Now we will calculate the frequency factor, and you are well aware of the fact that in the previous classes, when we have discussed um, about the transition state theory, and we came to know that the frequency factor is proportional to the entropy of the system. So if the entropy of the system is large, then we can consider the frequency of the system is also large. A was proportional to e to the power delta S activation by R, as far as I remember. So just look into that expression. So now we will actually calculate the frequency factor, that is your entropy factor according to transition state theory. So now this is your frequency factor. So we already know the electrostatic contribution to free energy of activation per mole. What is the value? Delta G activation per mole means for 1 mole. Na into ZA ZB into E square divided by epsilon DAB. Let us say this to be equation number 1. So from the knowledge of thermodynamics, we know that S is equal to minus del G by del T at constant pressure. So if at constant pressure you will calculate the change in free energy with respect to change in temperature, the value will be equivalent to the entropy of the system. So now we will use this equation 2 to determine the entropy of the system. So now we will calculate the electrostatic contribution to the entropy of activation. So electrostatic contribution to the entropy of activation. So this will be equivalent to delta S electrostatic of activation is equal to minus of delta G. Instead of G, I am writing delta G electrostatic activation by change in temperature by keeping pressure to be constant. This is equation number 3. Just now we will put the expression for delta G activation, and that is nothing but minus of del ZA into ZB E square into NA divided by epsilon DAB divided by del T and keeping pressure constant. Okay, so now the thing is that in this particular term of the free energy changed during activation process, we are calculating this change in this term with respect to temperature. Okay, so now the thing is that with respect to temperature, what will change? Will the charges will change with respect to temperature? No. Will the minimum charges? No, it is a constant volume, it will not change. From 1 mole of substance, will the temperature change? No, it will not change. The distance change? No, it will also do not change. So what will change with change in temperature? You already know. With change in temperature, the collisions happens, and due to the collision there is continuous rupture and formation of solvated atmosphere takes place. The cage takes place. The change in the structure of the solvent cell takes place, and due to which actually there will be change in the value of dielectric constant. Therefore, in this expression only the value of dielectric constant will vary with respect to temperature. Therefore, during the calculation, during the differentiation with respect to temperature, this will be the only variation parameter. So this will be, we will keep the constant term or the terms which do not vary with respect to temperature from the differentiation aside, and we will keep, as there is no more terms, we will use D, keeping pressure constant. Okay, so now what is the differentiation of 1 by x? The differentiation of 1 by x is nx to the power n minus 1, that is 1 za. What is the power of x? Epsilon is there, minus 1. Therefore n is your minus 1, that is equal to epsilon minus 1 minus 1, that is your minus 2, that is your 1 by epsilon square. And E, again differentiation of E with respect to temperature will also be there. Okay, now let us just rearrange the terms. Minus of minus plus, that means za into zb e square na by dab into 1 by e into, just I am writing 1 by e de by dt at constant pressure. So this term can also be rewritten as d ln epsilon. D ln epsilon. If you differentiate ln e, you will get 1 by e multiplied by de. So same expression you will get, de at constant pressure. So this is the equation number 5, which we got from electrostatic activation. This is the contribution of electrostatics during the entropy of activation. So you already know the fact that if we are taking the ionic solutions in water, that means we have taken an aqueous solution and we have maintained a continuity of the medium. That means the dielectric value will be almost the same. That is, the value will be remain about 80. Then we will calculate the change in ln epsilon of logarithm of epsilon with respect to temperature. So if the medium is continuous over a temperature range, then obviously the dielectric constant, which is the nature of the solvent, that will also remain the same. So in aqueous solution we can write in aqueous solution epsilon is about 80. The value of epsilon is about 80, and the term d ln epsilon by dt, that means the change in logarithmic of dielectric constant with respect to temperature keeping pressure constant, remains constant. This value remains constant, and the value is coming out to be about 0 minus 0.046 over a considerable temperature range. Over a considerable temperature change, the value is remaining at most constant, as the medium is almost continuous in nature. So if DAB, the value of DAB to be about 10 to the power minus 8 order, then delta S electrostatics, if we put all the values, then the value of delta S activation will be equal to Na we know, DAB we know, E is about 80, d ln E by dt is about minus 0.046. Then the value will come out to be about, this is the approximate value, minus 10 of Z into ZB. This is your next equation number 6. So this entropy of activation is talking about the frequency factor if we compare with the Arrhenius theory, and that means if, and what does this entropy of activation says? It says actually, if we change the product of the charges of the ions, that is Za Zb by 1 unit, then the entropy of the activation will decrease by 10 unit. So this we can write according to equation 6th, entropy of activation in aqueous solution should decrease by 10 units for each unit of ZA into ZB. As there is a minus sign, obviously the entropy of activation will decrease for 1 unit change in ZB, there will be change in 10 units. So as frequency factor, that is A, which we have dealt in the Arrhenius equation, is proportional to e to the power delta S activation by R. Therefore, if we change the base from e to 10, then we can write delta S activation by, obviously we need to multiply 2.303, and when you put the value of R, our value would be about 4.57, and if we put the value of delta S, that is equal to minus 10 ZA into ZB, 4.57, and the value that means here for 1 unit change in ZH product of ZB, your value will be equal to 10 by 4.57. That means numerically equivalent to 5. That means there will be about 5.2, that is 1 by 100. That means the value decreases, the entropy frequency factor decreases 100 times for every 1 unit change in ZB. Okay. So for today class, till today we have discussed about the double sphere model and we have completed the double sphere model. In the next class we will talk about the next model which will describe the ionic reactions, and the next model is your single sphere model. And in the single sphere model we'll actually assume that obviously the ions will move from infinite distance and they will approach each other to a particular distance, but whenever they will approach, in the double sphere model we have considered that a intact structure, a activated complex will be formed where the two ions will actually remain intact with each other. But actually in the single sphere model, actually what is happening, when the ions will approach to each other, they will form a single sphere, and the total charge of that single sphere will be the sum total of the charges of the ions which are approaching there. And therefore what is the change in the free energy, what is the electrostatic contribution, that we will calculate that. And after that, after going through that single sphere model, and we have already completed the double sphere model, so what is the consequences of this double sphere model and single sphere model, we need to read. So after completing single sphere model, we will actually read the consequences of ionic reactions, which we have just studied, the different type of models. Okay, so for this class this much only. We will meet in the next class very soon. Thank you so much.